Okay, here we go. So, we're continuing our talk. We're picking up basically right where we left off before the test. All right? So, in this unit, right, we started with graphing quadratic equations, right? And we had different ways to graph it. Sometimes we had your intercept form, sometimes we had vertex form, sometimes we had standard form, right? And we used different strategies for graphing and things like that, right? After we got enough with graphing and identifying the axis symmetry, identifying the vertex, identifying the zeros, identifying whether it was concave up or concave down, all that kind of stuff. After all that, we started to solve quadratic equations, remember? Okay? And we used like square roots, for example. So we started with like simplifying square roots, and then we solved using square roots in the actual equations, right? Then we did like factoring as well. We showed a little bit of factoring, and we also did completing the square to solve quadratic equations as well. And so finally, we're going to look at a formula that will allow us to solve any quadratic equation that we come across, okay? And this right here is that formula, okay? So it's called the quadratic formula, okay? And if you have a quadratic equation in standard form, and it's equal to 0, right? So it's got to be equal to 0, okay? So quadratic equation in standard form there, right? And of course, a is not equal to 0. Why do we need to stipulate here that a is not 0? What would happen here if a was 0? What would this actually be? Would it be quadratic still? So, Sky? Okay, that's a good point. Absolutely, yeah. If a was 0, we'd be dividing by 0 here, and that would be a problem. Also, if a was 0, what would happen to this term right here? Anybody? It would go away. It wouldn't be quadratic anymore. It would be linear. And then we'd just be able to solve a linear equation. And we know how to solve linear equations. The problem with solving this is that we have x squared and an x. And so it's hard to solve sometimes when you have both x squared and x. Okay? So quadratic formula is a way to solve a quadratic equation that will always work. But it's just sometimes you want to use other strategies because, they're faster. All right. Anyway, so here is the formula right here. Okay? X is equal to negative b plus or minus the square root of this whole quantity here, b squared minus 4 times a times c, all over 2 times a. Okay? You will not be required to memorize this formula. I'll be giving that to you. Okay? You'll be given it. But you need to know how to use it, and that is a challenge in itself. Okay? If you do want to try and memorize it, you can. There's like a million songs on YouTube that you can like look up, okay, of people trying to become internet famous by creating their own little quadratic song ditty. All right. There's one song that I know. It goes to Pop Goes the Weasel. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. All right. So there you go. You can use that to help you remember it if you want to. Otherwise, you don't have to memorize it. Like I said, I'm going to give it to you. All right. So we're going to kind of like use this eventually, but we're going to hold off on using this for right now. I'll come back and fill in the steps and stuff like that later. What I want to highlight, okay, is a part of the quadratic formula. This part right here, the b squared minus 4ac, that is known as the discriminant. Okay, it's from the quadratic formula, and like I said, it's called the discriminant. Okay, now, discriminant is very similar to what word? Discriminate, right? Discriminate, right? And we have this negative connotation about what discrimination does, okay? And this discriminant is related to that, okay? But not maybe in the negative sense, okay? Just in the more just like straight up meaning, whatever. Anyway, so let's take a look here at what we've got. So let's go through this table. I'm going to hold off on filling in this table for just a second. Let's go down here and take a look at this. Okay, we got a little table here I'm going to fill in. So let's take a look at our quadratic equation here. Okay, number 1. What's a here, number 1? Okay, a is 1, right? Okay, so a is 1. What's our b? 1 as well. What's our c? Negative 2. Okay? So when I go to do the discriminant, I need to take my b and square it. So I'll have 1 squared minus 4 times my a again, which is 1, times my c, which is negative 2. Okay? I guess I'm going to zoom in a little bit more on that. There we go. Okay? So again, right now we're not using the quadratic formula. We're actually just going to use a piece of it because this piece can actually help us determine some important information without having to do the whole quadratic formula. Okay? So I'm going to type this in my calculator. Okay? Please use parentheses when you're squaring something, right? Minus 4 times 1 times negative 2. Okay, I'm literally just typing in with all the parentheses and stuff like that. Hit enter. I get 9. Okay? Is it positive, negative, or 0, the discriminant here? Why is only John answering this one? This is an easy one. Which one is it? Is it positive, negative, or 0? Positive. Okay, very good. All right. So that means something. Let's take a look here. So now let's graph this and see how many x-intercepts this thing has. So I'm going to graph it. All right, x squared plus x minus 2, and graph it. Whoops, I need to adjust my window back, so zoom 6. How many x-intercepts does it have? 2. Okay, yeah, negative 2 and 1. That's right. Okay, it's got 2 x-intercepts. All right, let's try another one. Okay, this one, again, we'll do the discriminant here. What is our a for number 2? 3. What's our b? Negative 22. And what's our c? 7. Okay. And so we'll plug this into our discriminant. Again, that piece of the quadratic formula here. So b squared is going to be negative 22 squared minus 4. Minus 4 times a times c. Okay, and again, I'll just type that in my calculator here. Negative 22 squared. Negative 22 squared minus 4 times a times c. Okay, just type it in. Hit enter. 400. Okay, is that positive, negative, or 0? Positive. Okay, discriminant's positive. Now I'll graph it to see how many x-intercepts there are. 3x squared. Oh, that's supposed to be a 3x squared. Sorry, this should be a 3x squared here, folks. That's a typo for sure. Okay, that should be 3x squared. Minus 22x, and then plus 7. Okay. Okay, how many x-intercepts do we see? 2, right? 1, 2. Okay, just like that. All right, you guys go ahead and fill in the rest here, okay? Try the rest there. Do the same thing I just did. Do the discriminant, okay? And then see if it's positive, negative, or 0, and then tell me how many x-intercepts you see for the graph.
Is the 2x squared actually?
Sorry? It's supposed. Oh, yeah, sorry. This 2x should be squared as well. Thank you, Eric. Yes. Okay, everything else should look good there. Yes. How about you try some of these problems first, and then you can go, okay? See what you can come up with first. Okay. Get through number 5 if you don't mind. Try. Get to number 5, then you can go. Okay? So let's do 3, please. Okay. So go ahead there.
That one with graphing calculator so I can find
Yes. Yes. How many x-intercepts? Yeah, you got it. You got it. There you go, sir. Question, Jackson? Just anytime you substitute something in. Okay. Anytime you sub something in. So, yep. Essentially, not really just ignoring it. You just use the lead coefficients, right? A is the lead coefficient. B is then the coefficient for the x term. C is the coefficient for the constant. And it's in b squared minus 4 times a times c. So I'm saying you just plug in, and use parentheses when you're plugging it in. That's all you gotta do. Okay. So if you're unsure, I'm working on number 3 up here just to show you. If you like tried it on your own, you want to check yourself there. got number 3 up there for you if you're stuck. Okay, if you just want to check your work to make sure you're doing it right. Okay, and if you're stuck and you're not sure what's going wrong or something, I can come around and help you too. And our goal here is to try and see if there is try to see the relationship between whether you have positive, a negative, or a 0 discriminant. So if your discriminant is positive, negative, or 0, try to see if there's a relationship between the sign of your discriminant and then the number of x-intercepts. Okay? So you're trying to see the relationship between the sign of your discriminant, whether it's positive, negative, or 0, okay, and then how many x-intercepts your answer has, or your equation has. Let me show you. Let me see what you typed in your calculator. Tell me what you typed in your calculator. Type it in for me, please, and I'll take a look.
Oh yeah, no, never mind.
You got it okay?
Yeah, I got it.
Excuse me.
Actually, can you hit 0 x-intercepts?
Look at your graph. Have you seen the graph yet? Look at the graph of it. Like, did you graph the quadratic? Press the zoom and then 6. That'll get you to your standard viewing window there. Okay, so y equals, you got to type the function into your y equals there.
Now I gotta type that again.
Yeah, sorry.
There's nothing.
Hand is out. When you go, when she's back. Nancy? Oh, not that. Sorry. I mean the function.
Oh, okay.
Function.
Oh, the function.
Yeah. 2x squared minus 9x plus 13. You can see that the graph is not intersecting. In fact, there's no x-intercepts. Okay. All right, is anyone stuck? Okay, window range. So the error, who you hint, what the error, where your error is. So window. Okay, you can see here, this is your issue right here. Actually, right here is your issue. Your y and y-max are the same number. In other words, there's no like distance between them to show you. It's just 10 to 10. So it's just the same point. So you want to, the easiest way to fix that is press zoom, and then you go down to zoom standard. That takes you to the standard viewing window. So you have some data plotted in there too. Okay. So there it is. Okay. So how many times does that intersect the x-axis? Okay. Lauren, sorry, you had a question? Aaron, come on. Okay. Yeah. Look at your calculator. You'll press the y equals button. Yep. Type in exactly what you see. You don't put the equals 0 part, just like the what you see. Okay, and then see how many processes, how many times process x. So try pressing zoom and then 6. Let's see if it shows up now. Alright, let me see how you type it in. Maybe that might be part of the issue too. So identify your A, your B, and your C. Oh, don't type this in, type in the function itself. So type in the function, that's correct. Yeah. Say again, sorry? No, you want to call it B. B would be then -20 there. Yeah, you want to keep it exactly like you see it. Okay? And then put it in the B squared minus 4AC, create a simplify. Okay? Yes, Tyler. What are you trying to do? Exactly like to simplify these? So parentheses. Okay, and then let's type in -8. Close parentheses, and then square. Okay, good. A minus 4. And then parentheses 1. Parentheses, and then parentheses 16. Good. There you go. 0. So you equals 0. And then you want to graph the equation then. Okay, graph the equation, see what you got. So if your B was negative, you're saying? Well, it really depends. It doesn't necessarily have to be that way. So you definitely have to do B squared minus 4AC. If you do the whole, you have to do the whole calculation. You can't just try to say it's off. Just take B. It's got to be B squared minus 4AC. It becomes positive when you square it, though, because you're multiplying it by itself. Okay. Next, do you need a calculator or something? All right. Well, so I'll have to ask questions though. Okay. You have your calculator? Okay. So what you're supposed to do here is evaluate this. B squared minus 4AC. So you go to your quadratic here. What is A in this quadratic? There isn't right. There's a number. What number could you say? Yeah. A is 1. What's your B?
B squared, so B squared.
And what's your C?
Minus 4.
Okay, so A is 1, B is -8, C is 16. Plug those numbers in here. So it'll be B squared -8 squared times 4 times 1 times
It's
16.
a huge number.
You simplify that. You calculate to do it.
What's your A in that?
And then graph that same function and see what you get
4, right?
as far as
Your finger
how many
staring
zeros
at
you get.
20.
Oh, yeah.
So it's -20.
Okay. So question, Hannah?
So it's always minus 4, right?
Say again. It's always minus 4 AC.
Yeah.
You. This one should be 0.
Yeah, where was it?
For real?
There's
So
nothing.
then you retype it in. It shouldn't not be touched at all. I told you. Aaron, this is
So 4x squared
okay. You're gonna press okay.
minus 20x.
Sorry. You want to to do this math, you actually do it on your home screen here. So you do -9 squared minus 4 times 2. That like this. Okay. So you enter -23. So I'm like -27 right there. Okay. Now we're gonna graph this to see how many x-intercepts it has. So I gotta clear this out because I want the stuff with the x's in it too. Graph 2x squared minus 9x.
That's what you so we had seen the height, right? So we got
One.
closer to y. So that's gonna watch it.
See, it never goes to x-axis, not when there's 0 x-intercepts.
Just to see.
Okay. So that's what you're supposed to do here. Yes. Is that answer your question here? Yes. Yes.
And I'm at like 120 at this point. Well, because look, plug the transits, that's just gonna be a solid.
You see the graph here. So 0, 3
Right now
is
you
the
have
y.
to plug in y versus
y.
y.
Oh, I forgot to put
If it was the x-axis, you have a y coordinate.
4x
here.
squared minus
squaring the 20, then it's going to negative 20. You want to square negative 20, you got to put that negative 20 in parentheses. So that way you have left side. Okay? That's why you have to be careful. What do you think it is? How many times across the x-axis? It touches and doesn't. That's one. This is one. Yes, exactly. The only other or Mrs. Ray, how are you supposed to figure that one out? So look at the graph. How many times does your graph intersect the x-axis?
I'll check it.
Where's the way it intersects the x-axis? Right there. And just that one. Alright. In the interest of time, okay, we're going to show you the answers here. All right. Tyler, question? Yes. Okay. Here are your answers. All right. These are all your discriminants. 9, 400, negative 23, 0, 320, 0, negative 11, and 48. Okay. I went through and also checked whether they were positive, negative, or 0. Okay. And then I also identified the number of x-intercepts. What is the relationship between, well, if you have a positive discriminant, what does that normally indicate? How many x-intercepts? 2, right? All the 2 x-intercepts here have positive discriminants. How about if you have 0 x-intercepts? What kind of discriminant will you have? A negative discriminant. And if you have 1 x-intercept, what kind of discriminant will you have? It'll be 0. Yeah, it'll be 0. Okay? So, scroll back up to here. Well, I'll let you guys finish if you want to just write in there. Okay? I'm going to finish checking things off. Okay? But that's our summary here. Okay? If you go back up, it kind of clues you in right up here. Okay? All right, so what does this mean? Then here's our discriminant. If our discriminant is positive, that means greater than 0. How many solutions do we expect again? 2. You can see them right there. 1, 2, right? 2 solutions. Okay? If your discriminant is 0, again, just look at the graph here. How many solutions do you see? How many times does it cross the x-axis? 1. Okay, and then how many solutions does this show here? It never crosses the x-axis, so 0 solutions. Okay? So, the benefit of the discriminant, Brady, the benefit of the discriminant is that it gives you very quickly whether your equation has an answer and how many answers. All right? You could have 2 answers, you could have 1 answer, you could have 0 answers. What's the weakness of the discriminant, though? It gives us the number of solutions. What does it not give us? So again, the discriminant, if it's positive, you know you have 2 solutions. If it's negative, you know you have no solutions. And if it's 0, you have 1 solution. That's quick. That's quicker, right? But what does it not tell you? So, Grayson?
Vertex.
True, doesn't tell you the vertex. So again, we're told the number of solutions. What does it not tell us? Sky? Yes, what the solutions are. How do we find the actual solutions? Quadratic formula. Okay, the quadratic formula. Okay, so why do we use a discriminant? It's an easy way to kind of quickly determine if there's an answer to something or not, or how many solutions there are, right? But to find the actual solutions, you need to then take it a step further and actually use the full formula here and not just this little b squared minus 4ac that the discriminant is, okay? Do you see why we call it the discriminant now? When you discriminate, right, you're kind of separating, and normally it's people, right? We're separating people into groups, right? Okay? And sometimes you're showing, a certain favor towards one group and another group, right? That's, not a good thing, right? Here, though, in some situations, most situations, anyway, whatever. We're not going to get into that. My point is here, all right, what we're discriminating about is we're discriminating how many solutions there are. The discriminant will tell us how many solutions there are. That we discriminate between 2, 1, or 0. Okay? So, the steps here. How do we actually solve using the quadratic formula? Okay? Step 1, we're going to identify A, B, and C from standard form. I'll zoom in some more there if I can. There we go. Okay? Identify A, B, and C from standard form. Okay? We're going to then plug in and simplify the square root. Okay? Okay, and then 3, we will write 2 answers. Write both answers if there are 2. Okay. So, go ahead and turn the paper over here. Let's see this in action. Okay, let's see this in action. Okay, so once you have that written down, go ahead and turn the paper over. Let's see it in action. Here we got 2 examples to work through, and I'll do one more probably after that. Okay, on to the back. Did you get it okay? Lexi, were you still writing there?
Yeah.
Sorry, I'm too fast, huh? All right, there you go. Okay, yes, Alessandro. Can you just wait for this because it's going to be super important. This is the first quadratic formula problem you're going to see, so it's important you see this, okay? But then if you can go after we go through it, okay? Thank you for waiting. All right, we ready? Ready, Freddie? Oh, I see a few people writing. I'll wait. I'm sorry. The directions will also be on the back here too, so. I mean, they're on the back as well, so if you want to, you can. But they're on the back as well. Okie dokie. Okay. Still see people writing, so I'll wait. Snapping the quadratic formula. I got you. It's pretty cool. It's a pretty cool formula. I'm not gonna lie. That's right. Hashtag math torture. Oh, I'm not cool enough. I am not cool enough. All right, here we go. On to the back. All right, so first quadratic formula problem of your life. Very exciting. Very exciting. Okay, so first thing we want to do is make sure it's written in standard form. Is this equation in standard form? Yes, so I'll just like kind of rewrite it, I guess. Seems a little redundant, but so it goes sometimes. It is math class, right? All right, next we're going to identify the coefficients. They are A is 1, B is 3, C is -10. Okay, next step, substitute the values into the formula. Okay, now notice here, in the formula it's -b. So when you plug in, you're going to have a negative in front of the b that you plug in. So it'll be -3 in this case. Then there's the plus or minus already written for us. Square root. Remember, plus or minus just means we can add this value and we're going to subtract this value. We're going to do both, okay? We're going to add and subtract this value. That's why it's a plus or minus there. Okay, it's like an actual plus and minus sign. Okay, what number is going to go in here? B, so it's 3 squared. What goes in here? A1. What goes in here? C. Okay, and what goes in here? A. All right. We substituted in. We've made it. So far, so good. Okay, unscathed, right? No problem. We can plug stuff into formulas. All right, now is where it gets a little hairy. Simplify square roots and your denominator. Okay, so what's going to go, excuse me, what goes in this blank right here? Just 3, right? Still. In here, we're going to simplify this discriminant right here. We're going to simplify it, okay? So I'm going to type this into my calculator. Let me see if I can get this to show up. Okay. So I'm going to type in my discriminant here. 3 squared minus 4 times 1 times negative 10. Okay, you see I'm just typing it in like I see underneath the square root. Notice I am not using the square root. No square roots just yet. We're just simplifying what's underneath the square root. 49. Ooh. Why is that a good thing to see? Jackson. Okay. And it's a perfect square, too. We're going to be square rooting this bad boy, so it's good to see that. It makes it easy to simplify. Okay? Since our discriminant is a positive 49, we already know how many solutions are we going to have? 2. Positive discriminant, so 2 solutions. Okay? What's our denominator going to be? Yeah, 2 times 1 is 2. Okay? Now, the next step, split it into 2. Okay? What's different about these two things here? One's got plus the square root, one's got minus the square root. So how do we split it up? We split it up with the plus or minus. We make one answer with the plus, we make one answer with the minus, and we just repeat the numbers. So 3, 49, and the 2, 3, 49, and the 2. Okay. Now, you don't have to split it into 2 right off the bat. If you would prefer to simplify first and then split it into 2, you can reverse these 2 steps. You don't have to split it first and then simplify. Okay, it's your choice. In fact, I actually would probably be simplifying first in the future and then splitting it into 2. Okay, anyway, let's simplify this. So for this first one, we're going to have negative 3 plus, what is the square root of 49? 7, yeah, so we're just going to make it 7 instead of 49 there. Okay. For those of you folks that are still struggling with the square root stuff, it's not going away, okay? So come in for set, stay after school on a Tuesday or Thursday, okay? And I'll be able to help you out. But it's not going away, so make sure you get it down. Okay, let's do this one. We'll have a negative 3 minus, again, the square root of 49 is 7 all over 2. Okay, what is negative 3 plus 7? 4, and it's over 2. What is 4 divided by 2? 2. Okay, there's one of our answers. Whew. All right, what about this one? What's negative 3 minus 7? Yeah, negative 10 divided by 2? Negative 5. There's our other answer. We get 2 answers. Hey, and we have the answers now, 2 and negative 5. Okay. Did anyone see an easier way to solve this equation than what we did? So, yeah, Jackson?
Gone to the second step, but the first time you write it out, the square root and just solve.
Yeah, okay. I'm talking about back to the very beginning here.
Back to the beginning.
This factors, folks. This factors, right? This factors to be x plus 5, x minus 2 equals 0. And then you can set x plus 5 equal to 0 and x minus 2 equal to 0. And so you get x equals negative 5, and you get x equals 2 when you solve for the x's. So, okay, that's that much work compared to this much work. Okay? That's why quadratic formula, although it's powerful, it's also a lot of work. Okay? And that's why, so you want to be strategic. That's why we teach you all these different strategies. Different strategies apply, you know, to better different situations and stuff. All right. Let's move on to the next one here. Try this one now. Okay. 4x squared equals 2x plus 7. Is this in the correct form? No. What do we got to do to both sides here? I see what you're saying. Let's see. Would that work here? That might work. I think we want to leave, because that would give us a negative 4x squared on each side. And I see what you're saying there, Sky. That would be like the fastest way to do it. That might work. But I think for standard form, we want our a to be positive. I feel like we want our a to stay positive here. So we're going to have to do a little extra work. We'll subtract the 2x and the 7 over. And so we'll have 4x squared minus 2x minus 7 equals 0 then, right? So I'm subtracting the 2x from both sides, and I'm subtracting the 7 from both sides. Okay, so we end up with this. Okay, so Jasmine, what's our A in this problem? 4, positive 4, very good. Okay, what's our B, Jasmine? -2, very good. Yes, you do want to include the negative with the B there because it's a minus 2x. And then go ahead, what's C there, Jasmine? Very good. Okay, and again, the quadratic formula is x equals -b plus or minus the square root. B squared minus 4ac all over 2a. Oops, off the screen. There we go. Okay, very good. So, Dawson, what number goes in this blank right here? -2. Very good. All right. What goes in this blank right here? Let's go to Lauren. Lauren, what goes in this blank? You can look up here if you need to. I've got the formula for you. What number gets squared in the square root there? It's what? It's the b, so it's going to be -2. Okay. What number goes right here, Lauren? Not really, but let's just keep it the same order just for sake there. So it's going to be A first, right? So what's the A? 4. And then what's number here goes in here? -7. Very good. Okay. And at the bottom, let's go to Alex. Alex with an X. P. What goes in here, Alex? P? 4. Okay. Now, let's simplify our discriminant here. Okay, I'm going to leave the -2 inside there. Okay, so we'll have -2 squared minus 4, parentheses 4, parentheses -7. Again, I'm literally just typing in what I see underneath my square root right there, right? That's it. Hit enter. 116. Okay.
Did you mean to put -2?
Yes, because it's still in the parentheses there. So yeah, we're going to keep it that way. We'll simplify it eventually, but because of the way this is written, okay, we're going to continue with that there. If you wanted to in an earlier step, when you're doing it on your own, Grayson, you can make it positive 2 at any point if you want. But for right now, we're going to do that.
That would technically be positive.
Yeah, it will be exactly right. Okay, and then what is our denominator going to be? 8. Yeah, it simplifies to 8, right? Okay. So, and again, I don't know why we have to write it again. Well, we're breaking it up. That's right. So, okay, -2, I'll put the 116 and the 8 there. -2, 116, and the 8. Again, we're just breaking it up over that plus or minus. We make one plus, we make one minus, and now we have our 2 solutions here. Okay. And by the way, the discriminant tells us we have 2 solutions because it is what? Positive. Okay, let's simplify here. All right. Grayson, you already said -2 is really what? Positive 2. Okay. Is the square root of 116 a perfect square? No. Oh, man. We get to simplify it. What does it simplify to be? Sorry, what is it, John?
2 squared 29.
Okay. 2 square roots of 29. Oh, okay, so it's 4 times 29?
Yeah.
Okay, so it's root 4 times root 29. And so, yeah, the square root of 4 becomes then 2 square roots of 29. Okay, so this square root of 116, I'm going to change it to 2 square root of 29 all over 8. And then -2 becomes a positive 2 minus, again, that square root of 116 becomes 2 square roots of 29 all over 8. Okay, now, can I add 2 and 2 times the square root of 29? Can these be added together? No. We can't add them together. Can I subtract 2, take away 2 times the square root of 29? No, they're not like terms. So these numerators, I can't simplify them. But what I can do is break the numerator up over my denominator. So I can make it 2 over 8 plus 2 square root of 29 over 8. Same thing here. I can make it 2 over 8 minus 2 square root of 29 over 8. Can I simplify the fraction 2/8? Yes. Okay, if you're not sure, you can type in 2 divided by 8 in your calculator, hit math, enter, enter. But what does it simplify to be? 1/4. Okay, same thing here. This 2 and this 8, if I divide the top and bottom by 2, I get 1 over 4. So I get the square root of 29 over 4. And then same thing here. 2 and 8 simplify to 1/4. And then 2 and the 8 will also simplify to 1 times the square root of 29 over 4 there. And so these are our two solutions. Okay? Remember when we get zeros that had like really awful decimals and stuff like that? These are those kind of zeros. Okay? When you start having square roots show up that you can't simplify, those are those nasty decimals that you get. Okay? Questions on any of that? Yeah, go ahead. Max? Sorry.
I might have just missed it because I'm really.
That's okay.
Where does the 2 go from the 2 square root of 29?
The 2 from where?
From the 2 square root of 29.
Right here? We did a little side work over here. Okay?
No, I mean, where did the 2 go after you simplified?
Oh. So 2 and the 8 simplify, right? And so when I simplify, it's a 1, so then 1 times root 29 is just root 29 then.
Oh, okay.
Right? Because it's 2/8, which simplifies to 1/4, so it's 1 root 29 over 4, which is just root 29. Okay? All right. Yeah. Do we want to do one more example, or are we ready for the quick check?
Quick check, please.
All right, we're going to do the quick check. Sorry, that wins. All right. All right, so papers away, please. Papers away. The quadratic formula is provided for you on the paper here. Okay? It's just one problem. Yes. No, you have to put that away. You have to put it on your own, as much as you can, okay? Eric, we'll talk about the secretary. Hang on, I don't have to even worry about that. Okay, remember, use the formula there. I've given it to you. And just, and simplify as much as you can. Okay? Simplify as much as you can. Set it up. Just simplify it as much as you can. Thanks. Awesome. Perfect. All right. Actually, Mr. Stever's going to come around and get them. I have to check them really quick so that way I can make sure I organize them for my next class. Or for tomorrow.